Math 8, Unit 2, Transformations. Lesson 3, Part 2. Transformations, Reflection Coordinate Rules. What happens to the point? So here, the pre-image is the red shape. I've got two different images. The green shape is a reflection across the y-axis, and the blue one is a reflection across the x-axis. So I've already written down the points for all of these, all of the vertices on these three triangles. So remember, the red one going to the blue one is reflecting across the x-axis. Let's take a look at what's going on here and see what we can figure out. So if we look at the reflection across the x-axis, notice that the x values of -3, -4, and -1 become the x values of -3, -4, and -1. The x values do not change at all. So x goes to x. Okay, let's look at the y values. We've got 1, 4, and 1 become -1, -4, and -1. So it looks like all three of those went from being positive to being negative of the exact same number. So y is going to become the opposite of y. So this is the coordinate rule for reflecting across the x-axis. The x-axis, xy becomes the same x and the opposite y. If I reflect across the y-axis, notice that -3, -4, -1 become +3, +4, +1. They changed signs. So x becomes opposite x. Y goes from 1, 4, and 1 to 1, 4, and 1. They stay the same number. So for a y-axis reflection, xy becomes opposite x, y. So notice that y-axis, the y stays the same and the x flips. X-axis, the x stays the same and the y flips or changes sign. So to reflect the image in the x-axis, take the opposite of the y-coordinate, and to reflect in the y-axis, take the opposite of the x-coordinate. And here are the two rules that we just went over. Now you'll need to write this in your notes. Did we didn't start the I can statement there, did we? Yeah, we did. So underneath the I can statement, I can reflect, I can describe, perform reflections. If you reflect in the x-axis, so you do need to write this in your notes, xy becomes x opposite y. Reflect in the y-axis, xy becomes opposite x, y. Pause the video until you finish copying. The vertices of a triangle are A, -1, 1, B, -1, 3, and C, 6, 3. Draw the figure and its reflection in the x-axis. What are the coordinates of the image? Okay, this is already done. Well, I didn't write the coordinates of the image, but I did just want to point a few things out here. If point A is 1 unit above the x-axis, so point A prime ends up being 1 unit below. Point B and C are 3 units above, so B prime and C prime end up 3 units below. So like a mirror's image appears to be the same distance behind the mirror as you are in front of it, each corresponding part in the image is the same distance to the other side of the line of reflection. Okay, let's just look at this example where coordinate rules were used to reflect. The vertices of a quadrilateral are P, -2, 5, Q, -1, -1, R, -4, 2, and S, -4, 4. Draw the figures and its reflection in the y-axis. Because we're reflecting in the y-axis, the y will stay the same and the x will switch signs. So this one actually is pretty quick to do. It's been done down here in the table. You can see they use the rule of changing the sign for x and keeping y the same, and this gives these 4 new points. And over here you can see the picture of it. Now on this page are all 3 of the representations that you need to be familiar with. You need to know the verbal description. This is a reflection in the y-axis. You need to know the coordinate rule. XY is going to become opposite XY. You need to understand the picture that goes with those as well. Okay, so in your notes, example 1, please copy this down. Reflect triangle MOW across the y-axis. M is located at -3, 3, O located at -1, 5, and W at -2, 0. Okay, most likely you don't have any graph paper, so do the following to draw your graph. Take up several lines in your notebook. It looks like I went down about 7 lines and created an x-axis, and I even labeled it X. And then I do a line straight up. Now, making tick marks that are the same length as your notebook paper, I made 1, 2, 3, 4, and I'm going to do the negatives as well. And I can also number on the y-axis 1, 2, 3, 4, and 5. Okay, this isn't going to be quite as accurate as it would be on graph paper, but you can do a generally pretty good graph on lined paper if you're careful. And careful would include making these spaces be the same as these spaces. Okay, let's go ahead and draw. M is at -3, 3. So back 3 and up 3. So 3 and 3. And I'm going to label that M. O is at -1, 5. That's back 1 and up 5 units. And that I'm going to label O. Next, we've got W. W is at -2, 0. So I go back 2 and up 0. And that is W. This gives us our triangle MOW. Okay, we are going to reflect it across the y-axis. So y-axis, it's reflecting across this way. It doesn't hurt to make a quick note of that. Now every point is going to be the same distance to the other side of the y-axis. So right here, up at 5, I'm going to go 1 point to the other side and call that O prime. Here, let me get rid of this extra marking. So 1 to the other side and call it O prime. Now M is 3 units away, so I'm going to go 3 units to the other side, and that will end up right here, M prime. And then W is 2 units away from the y-axis, so I go 2 units to the other side and call that W prime. So we've got 2 of the 3 things that you need to always be able to connect. We have the description, reflect across y-axis. We've got the picture now. We don't have the coordinate rule, but we'll get that in just a moment. We're going to write the coordinates of the image. So M prime is located at 3, 3. O prime is located at 1, 5. And W prime is located at 2, 0. Now one last thing I want you to put here is the coordinate rule for this. Because it is a reflection in the y-axis, X is going to become its opposite and Y is going to remain the same. This now has all 3 things that you need to be able to connect. The verbal description, reflect in y-axis, the image of it, the visual representation, and the coordinate rule. The more times you can use the coordinate rule, the easier it will be to remember. If you have not yet finished copying all of this, you may want to pause it for a moment. Okay, let's practice together. Reflect triangle STL in the x-axis? Well, first I'm gonna draw it. R is at -3, 4. Back 3, up 4. So it is right here. S is at 5, 0. That's over 5 and up 0. Wait, this is supposed to be a rectangle? T is at 4, -2. And L is at -4, 2. Oh, okay, I see it. It is a rectangle. It's just rotated. Okay, we're going to reflect in the x-axis, so I'm going to make a note of that by doing an up and down mark on the x-axis. So I'll remember I'm flipping across there. So when we reflect, everything goes from one side to the other side the same distance. So let's start with R. R is 4 units above. It's going to become 4 units below R prime. S is right on the x-axis. So it is 0 units above. It's going to become 0 units below. It's the exact same point. Okay, so R, S actually didn't become a new point. It's the same point it was before. All right, T goes from 2 below to being 2 above. That's T prime. So T prime is now going to be 4, 2. And L prime goes from 2 above to being 2 below, which makes it -4, -2. And as I draw this, we can see this is kind of interesting. The reflection overlaps the pre-image. Now, this is something we're not used to in real life because we are unable to intersect with our image in the mirror. You can't travel through the mirror. It's just a virtual world on the other side. It's just light that's bouncing around. So some important things you need to understand. If a point is on the line of reflection, then its image is also on their line of reflection at the same point. For example, point S. And if a figure, the pre-image, crosses the line of reflection, then its image will also cross the line of reflection. Look at point T and T prime. It ends up crossing the line of reflection.